So now the topic is stability of the nucleus. So the stability of the nucleus, to check the stability of the nucleus, what we need is a proton number and we need a neutron number. So with the help of this we can calculate a stability. See, if the ratios of a neutron number to proton number, if that will be equals to 1, so then those elements we are calling it as the more stable elements. For example, if I take a helium atom, so this is having a mass number 4 and the proton number is 2. So the proton number is 2 and the neutron number is also 2. So because of that, our ratios of a neutron number to proton number, that is a proton number and N is a neutron number. So after calculation, what we get is 1. So if this ratio is increases to more than 1, then that is indicating a instability. Then those elements are unstable elements. For example, if I take a carbon, so this carbon is having a 6 proton and the mass number is 14. So mass number is 14. So this carbon is having a 6 proton number and neutron number will be 14 minus 6. So that will be 8. So if I take the ratios n by z, then 8 by 6. So that will be approximately equal to 1.2. So this will be approximately equal to 1.3. So compared to this helium, so this is unstable element because the ratios of neutron to proton number is 1.3. So this ratio is indicating the stability of the element. So the nature always wants more stability. So because of that, even these elements also has a tendency to move towards the stability. So this carbon is unstable, so it has a tendency to become a stable element. So because of that, this carbon will emit a nitrogen. So that nitrogen, so this carbon will emit one electron and so this will emit the nitrogen. So this nitrogen is compared to carbon, this is more stable because this is having a proton number 7 and a neutron number is also 7. So 7 by 7 we are getting a 1, so that is indicating a stable element. So this nitrogen is more stable as compared to carbon. So this is how we gonna calculate a stability of the different types of elements. And one more thing, to understand this stability process, we gonna mention about the proton number. So if that element is having a less than 20 proton number, if the element is having a less than 20 proton number, then these elements are more stable. So here you are not given neutron number as well as the proton number and directly mentioning only about proton number. So only about the proton number also we can mention. If that proton number is less than 20, they are also stable element, and more than 20 proton, so they are all unstable. They are all unstable. So how this is happening? How this stability is more and how this stability is less? This is because these elements are having a higher binding energy and these elements are having a lower binding energy. What is meaning of binding energy? The binding energy is nothing but a minimum energy required to break the nucleus. The minimum energy required to break the nucleus, or the minimum energy required to hold the nucleons at the nucleus. So we can define in two different ways binding energy. So here if we take a helium atom, so which is having a less than 20 proton atom, which is already stable. So we already calculated n by z, and from from that we have concluded that this is a stable nuclei. But with the help of this also, I will prove this is a stable element. This is how, see, this helium atom contains 2 protons as well as the 2 neutrons. So binding energy is nothing but I need a energy to break this nucleus. I need a energy to break this nucleus. So here I need a more energy, and if I take a different element, so which is having a proton number, different proton number and a neutron number. So this element requires very less energy to break this element. So this requires more energy and this requires less energy. So this is very interesting. So here I need a less energy. Sorry, here I need a more energy. Sorry, here I need a more energy and here I need a less energy. So this is having a more binding energy and this is having a less binding energy. So this is happening because, see here, only 2 protons are there, but these 2 protons are experiencing the strong nuclear force. So we all know that in the nature the strongest force is nuclear force. So they are experiencing the strong nuclear force. This proton as well as this proton, they are experiencing the strong nuclear force. They have strong nuclear force of attraction. Strong nuclear force of attraction and less electrostatic repulsion force. Electrostatic repulsion force. So this is a strong force. This is in the nature. This is a strong force, and this is a weak force. This is a weak force. And here what is happening is, see here. If I take, this is a proton number 1, and this is proton number 2. See, this proton number 1 and 2 are separated by some distance. So because of that, they are not experiencing any nuclear force, because we know nuclear forces are short range forces. They are short range forces. So because of that, there will be no nuclear force and more number of protons are there. So because of that, more repulsion forces they are generating. So if we gonna increasing the number of protons at the nucleus, then nuclear force of attraction will goes on reducing and electrostatic repulsion force goes on increasing. So because of that, we required a less energy to break the nucleus. So that is the statement I have made. So the more than 20 proton atoms means here a nuclear force of attraction is less. Nuclear force of attraction is less. And a more electrostatic repulsion force. So more electrostatic repulsion force. Repulsion force. So because of that, they are gonna unstable element and these are all stable element. So all these unstable element undergo radioactive decay process and these stable nuclei undergo fusion process. They will not undergo radioactive decay process because these elements are having a less binding energy. They want more stable. So because of that, they undergo radioactive decay process. Radioactive decay process, and these elements will not undergo radioactive decay process. They will not undergo radioactive decay process, and they undergo fusion process. Helium atoms combine together, and they will become a more stable. So because all the elements wants more stability, and here they undergo radioactive decay process and they undergo fusion process. See, if I take an example, for example, if I take a uranium-235, this is an unstable element. So after radioactive decay process, what it is forming is a thorium element. This thorium element is more stable as compared to uranium-235. So this is how we gonna study. This is how we have predicted some stability and instability about the different types of elements. So now we are going to study about the binding energy graph. So binding energy graph. So this is also important topic for your competitive as well as final exam. So in this binding energy graph, so binding energy for nuclei. So if this number, mass number will be like this. So mass number around 250. So x-axis will be mass number and y-axis will be the binding energy. So this binding energy will be goes on increasing, and this is increasing, and this is higher, and then it will goes on reducing. So this Fe, so Fe 56, iron 56 is having a more, this is having a more stable element, iron 56. And here from 0 to 20, I have already mentioned they are all more stable element. So this is, here comes a helium atom will come here. So this helium will combine together and they tries to make another element. So that is a more stable element. So that is more stable element. So if I mention uranium 235 here, see here from here to here a binding energy goes on reducing. This is because, as I already explained, number of nucleons will be increases from here to here. Number of nucleons are increasing. So this is a number of nucleons are increasing. So because of that, what is happening here is, to break this element we require less energy, more energy, and here is less energy, and here is very less energy. So this uranium 235. So if I take a uranium 235 is this element, so this require less energy to break. This is because there will be a less nuclear force. So if this uranium 235 undergoes a decay process, it will move towards the stability. So this element is nothing but a thorium element. These things will not undergo fusion process, they undergo fusion process, and these elements which are comes here, so these elements will undergo fusion process, or we can call they undergo radioactive decay process. So here Fe is a strong, the ratio of neutron to proton number is equal to 1. So I hope you have all understood about the stability of the nucleus, and in the next class we are gonna discuss about the mass defect, which is also important topic, and we are gonna discuss about the types of decay process. Thank you.